today we're going to talk about the sum and difference identities. And these, so here, there's two equations that you need to memorize. Okay, and you really need them. And if you memorize these, you get a lot from it for free without having to memorize it. So we have this equation, and I'm going to rewrite it just so as I write it, I can talk about it. So we have the cosine. If we have the sum or difference of two values, so this could be like pi over 6 plus or minus pi over 3. Cosine is a function. Functions don't distribute, values distribute. So what we want to do is we want to say, well, there's a formula for that. And the formula is, and what you want to do is remember for cosine, it's cosine, cosine, sine, sine. And then we just have AB, AB. All right. And so some of you may notice that we have this plus or minus, but here we have a minus and a plus. What that means is if I have a plus value, a positive value, then there's a negative. Like if I have A plus B, then it's cosine A, cosine B minus sine A, sine B. If it's cosine A minus B, it's cosine A, cosine B plus sine AB, sine A, sine B. So the signs flip. So it's cosine, cosine, sine, sine, and then the signs flip. And that's basically that's how I know it. So if we were going to go through, actually, let me give you there's also one for sine. We'll get to it in a minute, but let me give you both equations right now. So if I have the sine of A plus or minus B, it's equal to sine, cosine, cosine, sine. And it's, again, AB, AB. Sorry, AB, AB. And here the signs stay the same. Notice they don't flip. So if we have the sine of A plus B, it's sine A cosine B plus cosine A sine B, and vice versa. Okay, so let's see how we can use this. So first we're going to start off by saying, it says use the sum and difference identity for cosine.
Can you go back for a second?
Sure. I'll give you those equations a million times, don't worry about it. But you can write them down, yes.
Okay, thank you.
Okay, so it says use the sum and difference identities for cosine to find the exact values for cosine of 15 degrees. So they're giving you, obviously not just a hint, they're giving you the answer. So here I can say that the cosine of 15 degrees, well, I don't know the cosine of 15 degrees because I don't have my calculator with me, but I know it's equal to the cosine of 45 degrees minus 30 degrees. And then I have a formula for that. So remember, cosine is cosine, cosine, sine, sine. And then this is A and this is B. So it would be 45 degrees, 30 degrees, 45 degrees, 30 degrees. And also remember that with cosine, the signs flip. So because it's minus, that becomes a positive. So does everybody see how that formula works now?
Yes.
Okay, good. So now we know all these values. So we can say this is, well, the cosine of 45 is what?
Square root 2 over 2.
Good. And cosine of 30 is?
Square root 3 over 2.
Perfect. And then the sine of 45?
Radical 2 over 2.
Good. And the sine of 30?
1/2.
Perfect. So now I have the square root of 6 over 4 plus the square root of 2 over 4, which is equal to the square root of 6 plus the square root of 2 over 4. And that's my final answer. And it says we can check on a calculator to see if these are the same. They'll be the same. One will be in decimal form, which is not an exact answer. In square root form, it's an exact answer. And the only different, I'm sorry, excuse me? Is there a question? So the only thing different about B is that instead of subtracting, we would add, we're adding. So instead of addition, we would have subtraction. So what I mean by that, so if this is A, B, everything is the same, the numbers are the same and everything. The only thing different is that I would have the square root of 6 minus the square root of 2/4. Does everybody see why that is? If you don't understand, say so now or else I'm going to go on.
That's for cosine?
That's for cosine. Because cosine, remember, the signs flip. So I'm just going to keep writing the equation down. Hopefully you'll remember it. The more I write it, the more you'll remember it.
But for this one, it is plus, right?
Well, I was talking about for B. For this one, it's plus. For B,
Oh, it's
because
good.
the signs flip, it would be minus. Do you see that?
Yeah.
Okay, cool. That was all. That was my only point. I don't want to go through the whole thing again. I just wanted to show you the signs. The signs are different. So here the signs are different. Okay. Now, if you don't have the unit circle memorized, which is fine with me, I've never asked you to do that, and I still won't. What's
Is it
the-
at negative square root 2/2?
Yeah, because what's the reference angle?
180 and 45.
40.
45. See, that's how reference angles are really helpful. You don't have to memorize the entire unit circle. You can see that the reference angle for this is 45 degrees. Here, I'll just draw a picture for those of you who. So we know it's in quadrant 2. We're looking for this. This is 180. This is 135. This has got to be 45. So really, we want the cosine. I'm sorry. So the cosine here. So my reference angle, how can I write this? So my reference angle is equal to 45. The cosine of 45 is equal to square root of 2/2. And because it's in the second quadrant, it's negative. So negative the square root of 2/2. And that is the correct answer. It's been the correct answer. I just wanted to write it all out. So you know, you got it. Very good.
Sweet. And
Let's say I'm given that the sine of alpha is equal to 5/13, and it's in quadrant 1, and the tangent of beta is equal to negative 24/7, and it's in quadrant 2, and I want to know what the cosine of alpha plus beta is. Does anybody have any ideas?
Wouldn't you have to like draw a triangle?
You would have to draw a triangle, right? Because I don't really know anything about alpha, do I?
No.
No. So I'm going to draw a triangle. And here's alpha. So what does that mean?
The hypotenuse is 13 and the opposite angle is 5.
Okay.
Wouldn't you have to draw another triangle too
For what?
for beta?
Yes, good. So I have another triangle here for beta. And what can
Yeah.
I say about that?
Well, it's tan, so you can say opposite is 24 and adjacent is 7, but you have a negative fraction. So will one of the values be negative?
It would have to be, right?
Yeah. Can you pick
How can
either
you tell
or?
which one?
Oh. Well.
It's in quadrant.
Wait,
two.
wait,
yeah,
Cassidy,
quadrant 3.
Cassidy,
Oh.
Cassidy,
Yeah,
you gotta,
perfect.
you let him finish, okay?
Yeah. It's in the quadrant 3, so it will
It's in
be
quadrant 2.
how do
quadrant
you
2.
know that?
Oh, the
It says it
question
right
says
here.
Yeah.
Oh, I didn't see that.
So then it'll be the x that is negative. Therefore,
Okay, so what's negative?
The 7.
Yeah, 7.
Because it's on the
Okay.
bottom, right?
Yeah,
Mhm.
the 7 because it's on the bottom.
Well, I drew it like the bottom is an X and the top is, the side is a Y. That's how I
Alright.
drew
Yeah,
it.
cool,
You can draw it however you like, as long as you know what you're drawing.
awesome.
Okay, so now what do I do?
You add them,
I add them? I add what?
A and B.
No, because they're completely different. But I don't know what A and B are, do I?
Oh,
Those
it
If you had to find the missing side first,
Okay,
Yeah.
so let's find the missing side. So what's the missing side on the 5 and the 13, the alpha triangle? It's 12, right? It's Pythagorean theorem. So we have 5 squared plus x squared equals 13 squared. So 25 plus x squared equals 169. And x squared equals 144. So x equals 12. Good. Is it positive or is it negative?
positive
Yes, why?
is in the first quadrant. So
Exactly.
both X
First
and Y are
quadrant.
positive.
See, it says quadrant 1. Okay, how about the next one?
25.
Calculator for that unless you know it off by heart.
25.
Maybe 25.
Yeah, it's 25. Okay, so now we know a lot, right? We know everything about triangle 1. We know everything about triangle 2. And so I want to use my formula, which says, I'm sorry, not column, which says cos of alpha plus beta. So alpha plus beta is equal to the cosine of alpha, cosine of beta. And then the sign changes. So it would be sine alpha, sine beta. All right, good. So do we know what this cosine of alpha is?
Isn't it
Wouldn't
5
it
over
be-
13?
Oh, sorry.
What is it?
Isn't it
Adjacent over
5?
hypotenuse.
Wait, one at a time.
You can go, no, you're good.
But wouldn't it be what it gave us? Oh, that's the sign. So it wants
Negative
to
sign, yeah.
Oh, so
Adjacent over hypotenuse.
yeah, so 12 over 13.
So cosine is 12 over 13. Cosine of beta,
25 negative 7.
what is it?
20, no, sorry. Negative 7 over 25.
Negative 7 over 25. And then the sine of alpha they gave us.
Mm-hmm.
And the sine of beta,
Where's beta? Oh, there it is. So it would be 24 over 25.
okay, good. And so now we just kind of calculate it. So we
Mhm.
have negative 84 over 325
Mm-hmm.
minus 120 over 325, which is equal negative 204 over 325. And so look what I did. Without a calculator, I've calculated what the cosine of alpha plus beta is. Okay? Any questions? Okay, so now we're gonna use, oh wait, okay, so now we have sine. So I gave you the sine formula. It's right here down at the bottom. So it says, find the exact value of the sine of 19 pi over 12. Well, we don't know what 19 pi over 12 is. So we have to figure out how to find two values that we know where we could find the exact value of sine of 19 pi over 12. So this is the best way I know how for you to figure it out. So we start with, well, 19 pi over 12 is the same as pi over 12 plus 18 pi over 12, right? But that doesn't help me because I still don't know pi over 12. So I can say it's the same as 2 pi over 12 plus 17 pi over 12, which again does not help me because I don't know 17 pi over 12. So I go to the next one, 3 pi over 12 plus 16 pi over 12. Oh, this has possibilities because I know 3 pi over 12 is pi over 4. And I know 16 pi over 12 is 4 pi over 3. Do I know the values of sine and cosine at this point, at these points?
Yeah.
Wait,
So
what
that's a
are you
good one.
doing?
It's not just one answer, by the way. I could go to 4 pi over 12 plus 15 pi over 12, which is equal to pi over 3 plus 5 pi over 4. There's another one that I know the answer to, right?
Wait, Lisa, what are you doing?
I'm just kind of trying to find numbers that add up to 19 pi over 12, where I can actually reduce them to find value.
Oh, find the sign of this thing.
Yes.
Oh, okay.
Does that make sense?
Yeah.
So I just kind of, I can't reduce pi over 12 and I don't know the sine of, or cosine of pi over 12. That won't help. 17 pi over 12, again, I can't reduce it, 17's prime. But when I get into this next line, I can reduce that. I can reduce the next line, and there may be more if I keep going. But I don't need to keep going. I just want to find one set of values that work for me, right? So I can say that the sine of 19 pi over 12 is the same as the sine of, I'll use the first one, pi over 4 plus 4 pi over 3. Does that make sense to everybody how I got this?
Yeah, but I have a question. You can use any like coordinates that you know, like any combination of coordinates that you know that add up to
Yes.
19 pi. Okay.
Yes, it doesn't matter what they are. I mean, if I kept going, I'm sure I'd find more.
Okay.
Okay, but I usually pick the first one I find. I usually don't keep going, but if you don't like the first one, you can pick this next one. Yes. And then we use our formula. So this is equal to the sine of pi over 4 cosine of 4 pi over 3. My signs stay the same, so it's plus, and then I have cosine of pi over 4 sine of 4 pi over 3. And I can evaluate this, right? The sine of pi over 4 is
Radical 2 over 2.
radical 2 over 2. The cosine of 4 pi over 3.
Why'd you put the, oh, that's not a negative.
Negative half.
Negative what?
1 over 2.
Yes, negative 1/2, good. And then plus the cosine of pi over 4 is,
Radical 2 over 2.
And the sine of 4 pi over 3.
Radical 3 over 2.
Does everybody agree?
Yeah.
Yeah, so there's a mistake here. Who can find the mistake?
For instead of, it'll be a negative radical 3 over 2, right?
Yeah, this right here is negative radical 3 over 2 because it's in quadrant 3, right? 4 pi over 3 is more than pi and less than 3 pi over 2. So then we just multiply it out. We get negative square root of 2 over 4 minus the square root of 6 over 4, which is equal negative the square root of 2 plus the square root of 6 over 4. And that is my final answer. Everybody's with me so far?
Wait, so why is it? Well, it's negative because it's
Which
you're adding
one?
negatives.
The 4 pi over 3?
No,
So-
the whole thing's negative because both those fractions are negative, right?
Right. I just factor out a negative.
Okay. What does that say? Radical 6 over 4.
Radical 6 over 4, yes. All good?
Yeah.
All right. All right, let's see what we got here. So hold on. I just have to make your faces smaller. Hold on. Sure, we'll do this. Let's see. Let me just see. Okay, yeah, so we'll do one more of these. So it's telling us that the sine of alpha is equal to 4/5 and the sine of beta is equal to -2 over the square root of 5. And then they rationalized it. Find the exact value of cosine of alpha. So what's the, how do we find the value of cosine of alpha? Here, let me call on you. Hold on. Hey, Christian, you know how to find the cosine of alpha?
So then we'd have to make a triangle, right?
Good, yes, very good. And what do we know about this triangle?
So we have sine, and then the 4 would be opposite.
Okay,
And
so
the
this
5 would
is
be the
alpha.
hypotenuse.
Okay, good. Very good. And are they both positive?
No. It's in
Okay,
quadrant 2, right?
yes, good, because this is in quadrant 2. Very good.
So the adjacent would be negative.
The adjacent would be negative. What's the adjacent?
-3.
-3. Perfect. Hold on one second. Okay. And then, so now we know the cosine of alpha. So A, the cosine of alpha is,
Be -3 over 5.
perfect. All right. Does anybody want me to finish all these problems or can we move on? I'm happy to finish them if you want. It's
Hey.
kind of the same. We've already done this now.
Yeah, I think we're good.
We're good? Okay.